Okay, so our last topic to cover for Unit 1, and then we'll review for the test, is percents. And to understand percents, you really have to understand the word percent. It's actually a combination of two different words. Per, which means like miles per hour, miles per gallon, dollars per hour. It means for each or out of. And cent, if you think of years in a century or cents in a dollar, 100. So if you're given 38%, that's our symbol for percent, that literally means 38 out of 100. And we can write it as 38 out of 100 as a ratio. In fact, it's that simple to turn a percent into a fraction. 38%, 38 over 100. Of course, we're not done because we wouldn't leave it like that because it can be reduced. Both of those can be divided by 2 to make 19/50ths. So 38% would become 19/50ths as a fraction. Let's try a few more of those. 65% is going to become 65 over 100. What are we going to do with that? Reduce by 5 to get 13 over 20. Good. Let's look at 264%. That's going to be 264 out of 100. Nope. Percent is always out of 100. Remember, 100% is a full one item. So anything more than that has to be more than one. So this has to be an improper fraction because it's more than 100%. Now, as we break this down, the first thing I would probably do is I would do that. I can get 100 out of there twice with 64 left over. So that's 2 and 64 hundredths. And now that can be reduced. Both the 64 and 100 can be divided by 4, which will give me 16 over 25. Is that it? Need to remember the 2 yet. 264% is 2 and 16/25. How about 18 1/3%? It's still going to become 18 1/3 over 100. But we don't like having fractions within our fractions. So how do we go about getting rid of a fraction? Well, the easiest way to get rid of a fraction is to multiply by its denominator. So here, if we were going to get rid of the 1/3, the denominator is 3. So if I multiply by 3 on top and bottom, of course on bottom I get 300. On top, 18 1/3 times 3, I'm going to have to change it into an improper fraction. 18 times 3 is 54, plus 1 is 55, so that's 55 over 3. 3 becomes 3 over 1. The 3's cross cancel, and it's just going to be 55. Now that we have 55 over 300, of course, we can reduce by 5 to get 11 over 60. So 18 1/3% is 11/60, or 11 out of 60. (37.5%) of course is going to become 37.5 out of 100. You notice a pattern developing here? It's percent. It's always out of 100. Of course, it gets adjusted from there. What are we going to do with this one? Well, we don't like having a decimal within our fractions either. How do we get rid of the decimal? only one decimal place, so we'll multiply by 10 on top and bottom. So this is going to become 375 over 1,000. Then what? Can be reduced by 25. Okay, if we divide by 25, we're going to get 15 over 40. Both of those can be divided by 5. There's 3/8. 37.5% is 3/8. 3 out of 8. I want you guys in your notes to convert for me. (16 2/3%). Convert that into a fraction, and (56.25%). Convert that into a fraction. So the first one, walk me through it. 16 2/3 over 100. Multiply by 3 on top and bottom. I'll do the bottom, that's 300. On top it is 50. 16 2/3 times 3 is 50. And then?
1/6.
You can divide by 50 to get 1/6. How many of you got 1/6? Anybody not sure how we got that? Wants me to go over it more? Cool. The second one. Walk me through it.
We need to put 56.25 over
100, yep.
move the decimals 2 points, add 2 zeros to the.
Perfect. Well, yeah, moving the decimal 2 spots is the same as multiplying by 100. So that becomes 5,625 over 10,000. And then? Then you need a calculator. Let's divide by 5. That's going to give us 1,125 over 2,000. And then what? Probably can keep dividing by 5, huh? 25 would work too. 25 is going to give us 43 over 80. No, I did something wrong. 25 is going to give us 45 over 80. Okay, then what? Still divide by 5. 9/16. That one was a little trickier, but it'll get you there. Okay, so we can do our conversions from a percent into a fraction. Let's go the other direction now. Oh, sorry, before I do that, bless you. Let's go from a percent into a decimal. So if we have 38% and we want to go into a decimal, we know that that means 38 out of 100. Well, 38 out of 100, if I was going to convert that from a fraction to a decimal, I'd just divide. 38 divided by 100, which is 0.38. In fact, any percent, 72%, is going to become 72 out of 100. Divided by 100 is going to make it 0.72. So no matter what the percent is, if I am converting it to a decimal, I am dividing by 100. Whenever I divide something by 100, it just moves the decimal point 2 spots. 2 spots to the left. So 43% becomes what as a decimal? 0.43. 9% becomes what as a decimal? 0.09. 7.34% becomes 0.0734. 280% becomes 2.8. 3.5% becomes 3.5 is 3.5%, so 0.035. Good. 0.6%.
0.006.
Perfect. 0.006. 1/4%.
0.25.
That's a lot of people want to jump at that. Remember, 1/4 is 0.25, so it's 0.25%.
Yeah.
You still got to move the decimal 2 spots. 0.0025.
Oh, I get it.
Going the other direction, that is just as simple. If I have 0.67 and I want to turn that into a percent, well, a decimal, 0.67 is out of 1. A percent is out of 100. So I just need to multiply by 100 to get it there, which is just going to move the decimal point 2 spots back to the right, or 67. So 67 out of 100, or 67%. So 0.23 becomes what percent? 23%. 0.9 becomes 90%. 0.084 becomes 8.4. 2.6 becomes 260%. Any questions? Okay, so we can very quickly change from a percent to a decimal, or decimal to percent, by moving the decimal point, because we're either multiplying or dividing by 100. Going from a fraction back into a percent can be a little bit longer process. Let's start out with one that most people know right off the top of their head. 3/4 is what percent? 75%. Now let's look at why that's 75%. Well, 3/4 can be thought of as a ratio, as 3 out of 4. A percent is always out of 100. So there's a couple of different ways we can go about this. We can look at it as common fractions and changing the name. 4 would have to be multiplied by 25 to make 100, so 3 would be multiplied by 25 to make 75. So that's one way to approach it. But we can run into some that aren't so neat like that, like 7/8. What do I multiply 8 by to make 100? Well, it'd actually be like 12.5. That's not so easy to do. We don't want to mess with that. So there's got to be an easier way to convert them. Now what you would do is you'd do 100 divided by 8 would tell you what this is multiplied by here, correct? Then you'd multiply the 7 by that number. To simplify that, they've come up with a process called cross-multiplying. Cross-multiplying means you just multiply the diagonals like this. The 7 and 100 are on the same diagonal, so it's 7 times 100, which is 700. Now I'm going to put an x in here to represent that missing number. 8 times x is 8x. Those two cross products have to be equal. So 8x has to equal 700. So how do we solve that? Divide by 8. X equals 87.5. So let's use that. Let's say we have 4/5. If I want to turn that into a percent, I'm going to cross multiply. 4 times 100 is 400. I'll put an x here. 5 times x is 5x. How do I solve it? Divide by 5. So x equals 80. So this is 80%. I'll have you guys do this one. 3/7. Turn that into a percent. To the nearest hundredth of a percent. Our ratio. You get 42.86? Good. So 3/7 is 42.86% to the nearest hundredth of a percent. Any questions? Okay, so now that we can convert between the different forms from percent to a decimal to a fraction and back again, let's look at what we're going to do for some basic calculations with these. For example, we might have 18 is blank percent of 90. So when we look at these, I usually start with the percent. Now in this problem, we don't have the percent, but that doesn't mean we can't start with it. Blank percent is just blank out of 100. Remember, a percent is always out of 100. Once we have the percent, we match up the other numbers with the percent. So this missing percent has to match up with one of the other two numbers in the problem, either the 18 or the 90. The 100 here represents the whole amount, or sometimes what's called the base amount. Usually that's the whole thing. Sometimes it's just a beginning value, but still it's a base amount. It's what the percent is based off of, or what we originate everything from. So looking up here, which one of those two numbers, the 18 or the 90, represents that missing percent, or is connected to the missing percent? 18 is blank percent. The 18 goes with the missing percent. Of 90, you can actually even think of that as saying out of 90. So 90 would go on bottom. So now it's 100 times 18 is 1800. I called that x. It'd be x times 90 is 90x. So 90x equals 1800. We can divide by 90. X equals 20. So 20 out of 100, or 20%. Now you'll notice when we're working with these, when we cross multiply and get this equation, we always end up with an equation here that we're going to solve by dividing. So they shorten that process up. Rather than just cross multiplying and then solving the equation, they'll do just cross multiply and divide. So rather than getting this equation, they'll just do 100 times 18 is 1800, then divide by this number. Divide by the 90 to get the 20. I'll show you in my next example here. If I'm asked, 42 is what percent of 60? So again, I'm missing the percent. The percent is what I'm looking for. So it's blank over 100. 42 is what percent? So 42 is the number that goes with that missing percent. Again, of 60 or out of 60, 60 goes on bottom. Now to find that missing number here above the 100, the missing percent, we can just, instead of cross multiplying and solving an equation, we can just cross multiply and divide. 100 times 42 is 4200. Then divide by 60 will give us 70. So that is 70%. We could ask, what percent of 80 is 32? Again, we're missing the percent. So blank over 100. We have the 80 and the 32. Which one matches up with our missing percent? A lot of people are going to say the 32 because it's smaller, right? In this case, that is correct. But it's not just because it's smaller. You got to look at the wording. In one like this, because the wording is a little funny, what I normally do is I cover up one of the numbers. I'll cover up the 80. Well, the of goes with the 80. So what percent is 32? That seems to flow. That works. If I were to cover up the 32 instead, that's what percent of 80? That doesn't work. The 32 is the number that's linked to that missing percent. The 80 goes on bottom. And just like we mentioned before, we'll cross multiply 100 times 32. That's 3,200. And then divide by the other number, the 80 here, to get 40. That is 40% of 80 is 32. Here now, we have the percent. Blank is 90% of 60. So we'll start out with the percent again, 90 over 100. Now there are always two other numbers in the problem. In this case, it's the blank, the missing number, and the 60. Which one of those goes with the 90? Blank is 90. So the missing number goes with the 90. So the 60 goes on bottom with the 100. Now we're still going to cross multiply and divide. We're just going to be going in a different direction. 90 times 60 is 5,400. Divided by 100 is 54. So 54 is 90% of 60. Similar question, just worded a little differently. What is 130% of 40? Well, we have the percent, 130, so it's 130 over 100. Now this is the first one we've run into where the percent is larger than 100. 100, remember, is a full amount, or 1. So what does this tell us about what we're going to get over here on the other side? The top number is going to be larger than the bottom number. Now we have the missing number, the what, instead of a blank, and we have the 40. Which one of those goes with the 130? The blank, the what. So the 40 goes on bottom, and we will cross, multiply, and divide. 130 times 40, 5,200, divided by 100 is 52. So 52 is 130% of 40. Here, 25% of 80 is blank. Tell me how to set it up. 25 over 100. With the 25, is it the 80 or the blank? The blank. 80 goes on bottom. Cross multiply. 25 times 80. 2,000. Divided by 100 is 20. 25% of 80 is 20. Another one that's slightly different. Again, we have the percent. 42 is 60% of blank. We'll start out with the percent, 60 over 100. We have the 42 and the missing number. What's that?
42 over.
42 goes with the 60 over the missing number, with the blank, or the x. We're still going to cross multiply and divide. Again, it's in a slightly different direction. 100 times 42 is 4,200. Then we'll divide by 60 to get 70. So 42 is 60% of 70. %, of blank is 120. Tell me how to set it up. 80 over 100, okay. Yeah, the 120 goes with the 80 over my missing number. So cross multiply. 100 times 120 is 12,000. Divided by 80, 150. 80 is 150. 80% of 150 is 120. Now, some of you, like me, may have been taught something called the rate method of percents when you were young. The rate method simply involves turning the percent into a decimal. So you wouldn't work with 60%, you would work with 0.6. Let me show you how that works. Let's go back up here to the top.
This is just another way.
This is just another way of doing the same problem. Yep. So if I was asked, well, let's go down here. I'll start with this one. Blank is 90% of 60. The way we would have done that is we take our percent, 90%, we turn it into a decimal, which would be 0.9. And in this case, we'd do 60 times 0.9 would give us 54. There's our answer. Seems pretty simple, doesn't it? Or down here, 130% becomes 1.3. We take the 40 times 1.3 gives us 52. Well, that method almost seems easier, but there's a reason why I didn't show you that first. Because we get down to this one here, 60% is 0.6. But we're not going to take 42 times 0.6. We're going to have to take 42 divided by 0.6 to get 70. Same down here. 80% is 0.8. It's 120 divided by 0.8 to get 150. The main reason I don't use the rate method in class, if you know it and you like it, feel free to use it. The main reason I don't use it is there's a lot of errors made because you use it the wrong way. You know, here you got to decide, once you've changed your percent into a decimal, you have to decide, do I multiply or do I divide? With the proportion method here, you just put the numbers in and it's always cross multiply and divide. The calculation is always the same. In fact, with our rate method, we can come back up here. 42 is what percent of 60? Well, we're missing the percent. So what we have to do is we have to divide 42 divided by 60 is 0.7. Then we move our decimal point to make that a 70%. So not only do you have to decide whether you multiply or divide, but then sometimes you got to move the decimal point first. Sometimes you got to do the division and move the decimal point at the end. So like I said, if you were taught the rate method and you're good at it and you like it, feel free to keep using it. If not, like I said, I really like the proportion method because it saves on a lot of mistakes. The other reason why I like the proportion method is when we get into word problems and problem solving, things seem to fit into place more. For example, let's say a patient is receiving 120 milliliters of, for a generic drug in this class, we use the word serum. That way I don't have to name off drugs that I'm not sure what they are used for. 120 milliliters of a serum, of a drug. Doctor orders the drug to be increased by 48 milliliters. What percent increase is this? So again, we're looking for a percent here. blank out. We know something's going to be out of 100. Are we given the percent? No. So we're going to leave that blank. We have to ask ourselves, though, if we had this percent here, what would it represent? Now, what percent of the increase? That represents the increase. On the other side, or the other side over here, we're going to have numbers. Not percents, but the numbers. A measurement. Milliliters, dollars, something. So of the other numbers, what other number also represents the amount of the increase? The 48 milliliters. Now, before I just put the 120 down here and go on with life, does it make sense for the 120 to be on bottom? Well, remember, the 100% we said is always either a whole thing, the whole thing, or it's a starting amount. Is the 120 a starting amount? Yeah, we started with 120, and then we were increased by 48. So it does make sense. So now to find that percent, we cross multiply and divide. 100 times 48, 4,800, divided by 120 is 40. That is a 40% increase in medication. A patient has blood glucose level of 160 milligrams per deciliter. Doctor recommends a 30% reduction. How much does it have to be reduced? Obviously, we're dealing with percents. There's going to be something over 100. There'll be something on the other side. Do we know the percent? 30. So 30 over 100. The 30 represents the reduction. On the other side, what number represents the reduction? The number we're looking for in this case, right? How much does it have to be reduced? So the missing number represents reduction. So the blank goes across from the 30. Of course, the 100%, like we said, is the starting amount or the base amount. Is the 160 a starting or a base amount? Yes, it is. So we cross multiply and divide. 30 times 160 is 4,800. Divided by 100 is 48. So 48 milliliters per, or milligrams per deciliter is required. Of reduction is required. Any questions so far? Okay. Let's say that a patient has a level of 80 milligrams per deciliter in a urine test. In a second test, we get a new level of 360 milligrams per deciliter. What percent of the old level is the new level? So here we're looking for a percent again, so something's out of 100. Perfect. 360 over 80. It's what percent is the new level out of the old level? That means the old level has to go on bottom, the new level on top. We will cross multiply and divide. 100 times 360 is 36,000. Divided by 80 is going to give us 450, or 450%. Let's say a new medication works 2 3/4 times faster than the old one. What percent is this? Well, all this is asking you to do is change 2 3/4 into a percent. Of course, we cannot change a mixed number into a percent. What do we have to do to it? Make it an improper fraction. 2 3/4 becomes 11/4. 2 times 4 is 8, plus 3 is 11. And now, of course, we're going to make that out of 100, which will give us 11 times 100 divided by 4 is 275. Any questions? Okay, what I'm going to do is I'm going to end this recording